Hi, everyone, and welcome to week 5. So, this week, what I'm going to do is I'm going to have a video. I'm also going to, I'm sorry, let me play my show. I'm also going to post, like I did last week, for this sort of step by step running a statistical test. So, hopefully, you guys found that helpful. But just based on some of the emails I got and some of the things I've seen, I thought this week, in addition to that, I just wanted to spend some time talking about these different tests and kind of what we're doing. So I know you have the book and you're reading that, and you can probably follow along if you're able to finally get your data downloaded. But it's also important that you understand why you're using different tests at different times without and what's sort of behind that. So I just am going to start by reviewing kind of what chi-square and t-tests are and why we use them. And then this week, what we'll be adding in is ANOVA and regression. And sort of, again, this video is not going to be the kind of how to or how to look at the data, but more of a understanding why we're running those tests and when you would decide to run which test based on the data that you have. So the first thing I want to talk about, and this is something that the exercises talk about, I'm just moving myself, are this idea of type 1 and type 2 error. And I think the reality is, in using these, this is more of a conceptual thing, but this is also whenever you see like a political survey right now and they talk about the standard margin of error, that's what we're talking about. So what is the possibility that you have run your test but you came up with the wrong answer? So, and this isn't based on something that you did wrong. This is just built into the data. So we have two types. We have type 1 and type 2. So type 1 error is when we reject the two null. So we claim there is a significant difference between two groups when there actually is not. And then a type 2 is when we fail to reject a false null. So then we claim they're false null. So we claim there are no difference when there actually is. So remember, the null hypothesis is always, we start with this idea that there is no significant, let's just say, difference or relationship between variables. So I would say, again, if you're in the political realm, the null is there is no difference in the likelihood percentage of people that are going to vote for Biden versus Trump. Like, they're basically in a statistical dead heat. Now, let's say there actually was a difference, and I said that, like, no, they're the same, we would have a type 2. So where this error comes in, and this is what we talk about the margin, and this is why when we're looking at those p-values, and we'll say things like it's significant at the 0.05 value. So the way statistics works is we take whatever numbers and they become standardized, and then we talk about z-scores. So one of the great things about doing statistics now is, even though programs like SPSS can be very frustrating, it does a lot of the work for us. So if you were looking in the chapter, it actually shows you how you can standardize data and look up z-score values and all of those things. But what happens is data exists on kind of this normal curve, and so we can assume, if we have done a good job of sampling, that, the majority of responses are going to fall in here within one standard deviation of the mean. And then we have 2 standard deviations in the mean, 3 standard deviations of the mean. So this p at 0.05 value, if we are measuring at that level, what we are saying is that there's a 95% chance that the true actual value, so the true actual percentage of people that are voting for Biden, or the true actual percentage of people that are voting for Trump, there's a 95% chance that it exists within here. So that's where you get the plus or minus of 3 to 5. And so we, a lot of times in statistics, talk about this p of 0.05, which is a 5%. And so there's at both tails. Sometimes you'll get at the 0.01, but really that's arbitrary. You could do it to a 0.02 and you can set that. But that's why when you are looking at those charts and we look at the p-value or the significance value, and we're always looking for a number that is 0.05 or less. And that tells us, yes, this is truly significant. If it's larger than that, it is not. So that is what that means when we're talking about it. We're saying we are 95% sure that this information is accurate. And if that value is greater, then we're going to say, we're going to accept the type 1. Or we're going to accept the null and say, nope, they're really statistically not different. So let's talk about the different tests. So the first one you guys did last week was the chi-square. And so if you remember the week, we talked about different kinds of data and, are they continuous or are they categorical, nominal? And I wrote ordinal and that should say nominal. And I'm so sorry. Can you tell it's a Monday morning? Hold on one sec. I'm going to change that because that's going to drive me crazy. And if you've ever wondered if I do these live and don't reuse them, now you know this is what I do. So a chi-square is when we're comparing the relationship of two categorical or nominal variables, and these have two categories. So this is kind of a 2 by 2. So some of the questions you could ask is there a statistical difference between the number of males, oh my goodness, guys, that are communication majors and the number of women who are communication majors. So what we're saying here is it, if let's say is it just chance that there's a slightly different number, or is there actually something going on there, right? And then you would run that test. And so if you had a normally distributed sample, you would assume, for example, if you had half men and half women, that the number of women who were comm majors would be very similar to the number of men who are comm majors. But if you find a difference in that number, let's say per every 100, for every 100 females, 56 are comm majors, and for every 100 males, 12 are. You in your mind are like, yeah, that's a big difference, but you would need to test that. And then another example would be, is there a difference between domestic and international students in the number of communication majors? So again, and the communication majors, how that becomes a nominal variable is just a yes, no, I am not. So that's when you use chi-square. So then the next one we talked about was t-test. So this becomes a little more advanced in that we're still looking at two groups. So we have, male, female, national, international, so many things like Indiana resident, non-Indiana resident. If you're looking at this in marketing, current user, non-user. But what we're comparing them on is a continuous variable. So some kind of ranking. So do males and females vary on the value? Oh my goodness. They see. This is like a really good lesson that I should proofread before I start doing this. They see in a communication degree. So I still have two groups, but what I'm wondering is, what if I take the average, like on a scale of 1 to 5 value for what males say versus the average value of what women say, is there a statistical difference between those two groups? So the big thing here is you start with a category, nominal 2, and then I compare it on that kind of thing. So a ANOVA is basically a t-test, but it's just all of a sudden, instead of having just two groups, you can have multiple groups, but just the math doesn't work. So then we introduce ANOVA, and I'll make a slideshow today to talk about how to run this, but the idea behind it is exactly the same. So determining if there is significant difference between 3 or more groups. And the way ANOVA works is I can determine maybe there's a significant difference. So here I said, are there differences between year in school and likelihood to recommend getting a communication minder? So in here, I have 4 groups, right? I have freshman, sophomore, junior, senior. And I want to know, is a certain group more likely to recommend, you know. So you could hypothesize like people who are further in the program might be more likely to recommend because they see the value, etc. So I have 4 groups and I compare that. But potentially there could be a significant difference between freshmen and seniors, but no significant difference between juniors and seniors, etc. And so the ANOVA is going to look at all of those relationships and you can determine which groups have a significant difference. So that's ANOVA. So all the tests we've been looking at so far are really just looking at, is there a difference between what different groups report? Is there a difference in their data? So the next one is correlation, and then the book also talks about regression. And what correlation is we're going beyond just looking at differences, and we're saying, is there an actual relationship? So is there some kind of relationship? So if I answer a certain question a certain way, am I more or less likely to answer another question in a similar way? So is there a relationship? Now, very, very important, and I'm sure you've heard, correlation does not equal causality. So just because, let's say, one of the questions is, how likely are you to eat breakfast every morning? I'm a huge proponent of breakfast. It's my favorite meal of the day. So I would say very likely on a scale of 1 to 5. Now, they could ask me another question and say, you know, how satisfied are you with your job? And let's say I said very satisfied, 5 to 5. So, but if I took a large sample, we could see, is there a relationship between people who eat breakfast every day and people who are satisfied with their jobs? And maybe there is. But I would have to do different kinds of testing to find out if eating breakfast was the cause of that. But I would at least know. And then you can have negative correlation. So sometimes if I'm more likely, if I answered this way, I'm less likely to answer high values that way. So here, like an example would be, is there a relationship between political leanings? So let's say I gave you a scale, like, are you lean more Democrat, more Republican, and your beliefs about healthcare and how you support them? And oftentimes we can guess that there is going to be a relationship, but sometimes those relationships are surprising. The biggest thing to remember, you cannot claim causality, but you can know how they're related. And then when you get to regression, one of the things that you can do is you can start to predict and create a formula that, you know, if this person says this, I can predict that they're also going to say that. So those are kind of the 4 basic tests. And like I said, after I finish this, I will work on putting together a slideshow and I'll very carefully proof it. So thank you for your patience with me. And again, keep asking questions. I saw someone put, you know, this idea of you guys meeting together in a group and kind of talking about things. I think that's a great thing. This class is very different than the other classes. And I think sometimes just because it is numbers and things, it can be intimidating. So also, if there's additional things I can be doing to help you understand, I'm super happy to do that. So everybody have a great week.